All right, 4.6. We're going to start off with the parent function y equals tangent x. Again, I want you to use a clean sheet of paper. You might need two before we're done. So we did tangent last year, but we're going to take it up to a pre-calculus level today. So the period length for tangent is pi. We learned that last year. There's no amplitude. Yesterday when we were graphing sine and cosine, we said that amplitude was the absolute value of A, but then we wrote out a definition. Can somebody restate amplitude in their own words? Like, what did it actually mean? Tyler, what do you think?
It's like from the middle to the top or bottom of the graph.
Okay, so it's really a distance, right?
Yeah.
Isn't it either from the middle to the top, middle to the bottom, or sometimes we say it's half the distance from the minimum to the maximum. But it's a distance. So if you remember last year, do you remember tangent? When we actually do this, tangent went forever and ever up and forever and ever down. So it doesn't make any sense to say that it's half a distance of infinity. Okay, a plus infinity and a minus infinity. So there's no amplitude. Now we need to talk about a vertical asymptote. Tangent, we can rewrite as sine over cosine. And a vertical asymptote occurs where the denominator equals 0. And you've canceled out any common factors so we don't have a removable discontinuity. But it's going to occur where cosine x equals 0. So if I need to, let's draw this unit circle. And if the ordered pairs go around cosine comma sine, those are the x coordinates. So where do you see x coordinates of 0? At what radian values?
Top and the bottom.
Okay, let's say pi over 2 and 3 pi over 2. Let's say that instead of the top and the bottom. All right. We're going to be consistent with tangent like we are with sine and cosine. We're going to go 4 tick marks to the right and call it the period length. Now we're saying that there's a vertical asymptote at pi over 2, so we'll plot that. And it says that there's another one at 3 pi over 2. Well, I don't see 3 pi over 2 right now. How many tick marks would I need to add to get to 3 pi over 2? 2, right? Because 1 tick mark is pi over 4, 2 tick marks is another pi over 2. So that's 2 pi over 2, and here's 3 pi over 2. Now I want you to think about it. There are 4 tick marks in between the vertical asymptotes. So I can actually count left, 1, 2, 3, 4, and there would actually be another vertical asymptote at negative pi over 2. Now we want to, in pre-calculus, we want to be able to write the vertical asymptotes in general. So I'm going to take you to an abstract level here, and I want you to just write it down, and then we're going to think about it. X equals pi over 2 plus pi n, and I'm going to use some new notation, where n is an element of the set of integers. Okay, this little e symbol means is an element of. Capital Z is the letter for the set of integers. We don't use I because I is reserved for imaginary. Irrational, they use the letter Q. If you get to some some advanced math. If you're going to go into engineering, you'll go through Calc 3 and differential equations. So you'll see a little bit more of that. But let me say it again. It's x equals pi over 2 plus pi times n, where n is an element of the set of integers. So I don't expect you right away to get this. This is something that we're going to have to practice. The first positive one is at pi over 2. And the distance between vertical asymptotes is pi. So every time I add a pi, I'm gonna hit the next vertical asymptote. The n means I would add 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. But I also could make it -1, and I would be subtracting 1 pi, subtracting 2 pi, subtracting 3 pi, and so on. Okay? Now, we need some points. Tangent is sine over cosine. So let's start with 0. If I want the tangent of 0, this is sine 0 over cosine 0. Well, I've got my circle, and the sine of 0 is 0. The cosine of 0 is 1. So I'm going to plot the point 0. The first tick mark is pi over 4, or 45 degrees. We've done tangent pi over 4, tangent 45 degrees enough numbers of time. We should know what that is, right? What is it? It's 1. And then if you do -45 degrees, you're now just in the 4th quadrant. Tangent's negative there. So it's just -1. So with tangent, you're going to find your vertical asymptotes and plot your 3 main points. So then it's going to repeat. Okay, and then there's 2 full period lengths. What I do is I don't memorize this, but I can figure this out every time. And so then as you're toggling between all 6 trig graphs, you're like, okay, where are the asymptotes on tangent? I do a quick one, and once you do this enough times, it's like, okay, it takes you less than a minute to generate one. Really what ends up happening with the tangent curve, if you will make 4 tick marks and call the 4th tick mark the period length, the asymptotes are always 2 to the right, 2 to the left, every time. Okay? So that'll make your life a little bit easier. So then let's do a transformation here. Suppose I want to graph y equals 3 tangent x. Well, the period length is still pi. There's no amplitude, but there is a. Okay, there is an a. We don't need to do the vertical asymptotes again because I didn't move this left or right, or I didn't change the period length. So the vertical asymptotes will be 2 to the right, 2 to the left. I do need to make 2 more tick marks though. So then the vertical asymptote is going to be x equals pi over 2 plus pi n, where n is an integer. And I will ask you to do this formally this way. And then you are going to get the same 3 points, except instead of it going up to 1, it's actually going to go up to the a value. So if a were negative, it would just be flipped. Make sure as you draw this that you don't have something that looks like a line, and you don't have anything that looks pointy. This really is a smooth curve that's increasing. In calculus, we're going to talk about concavity, something that's concave up or concave down. This actually changes concavity. It's like concave down, then becomes concave up, which is kind of a neat feature. All right, everybody have this? So when you're graphing, I'm going to want to see the period and vertical asymptotes with tangent and cotangent. Okay, let's try this one. Y equals tangent 2x. Remind me to tell you about the board out, or maybe if you've talked to Alex. I actually figured out the 0, 1, 2, 3, 4, 5, 6, and 9. I haven't figured out 7 and 8 yet. What you're trying to do is you can only use add, subtract, multiply, divide. You can do square root, not cube roots. You can't square it. You can do factorial, and you can do parentheses. And you're trying to generate 6. So like 2 plus 2 plus 2 is 6. 3 times 3 is 9. Minus 3 is 6. So I'll leave that up because I have not had time to check 7 and 8. But I got the other, actually Michaela did the 1, 1, 1. That's the one I could not figure out. That I was like, oh. Once you know it, it's like, oh, I should have known that one. But it's pretty cool. All right, so A is 1, and then the period is pi divided by 2. So let's watch how this changes our graph. So you're still going to make 4 tick marks to the right and call it the period length. And so then if it's tangent, the vertical asymptotes are at 2 to the right, 2 to the left, but they're not at pi over 2. They're at pi over 4. So then I need to add 2 more tick marks to get the next vertical asymptote, but what would I label it? Good job, 3 pi over 4. Because 2 tick marks is pi over 4, that's 2 pi over 4, 3 pi over 4. We'll attempt to write that in a moment, but let's go ahead and plot it. The A is 1, so I'm going to go to the right one. Try to make that a nice smooth curve, you'll just need to practice. Okay, so what I do when I'm first trying to figure out how to write the vertical asymptotes, I'll write out the first couple or so. And so I know it's at pi over 4 and 3 pi over 4. So how could I write this in such a way that it would take care of infinitely many? Anybody want to try it? When we get you started, you'd start with your first one, and then what's the distance between them? Not pi over 2. Or, no, it is pi over 2, sorry. That is pi over 2, yeah, because that's 2 pi over 4, which is pi over 2. So here's how you would write it. X equals pi over 4 plus pi over 2n, where n is an integer. I don't know why I keep cutting that top of my E off there. Okay? Alright, now let me give you one, and I want you to try to go the whole way through on it, and then we're going to do cotangent. Alright, try this one. Make sure you identify the period length write out the vertical asymptote formally. A reminder that tangent has a period length of pi, so it's pi divided by b. Your asymptotes will be at the second tick mark left and right, but I'll add 2 more. So now, instead of this going up to 3 when I go right, it's going down. And then it's going to repeat the pattern. Alright, then the vertical asymptote on this one is just like the last one, pi over 4 plus pi over 2n, where n is an integer. Okay, any questions on that? Alright, so that's tangent, and we did tangent last year. Now we're going to do the parent function cotangent x. Okay, there's no amplitude again for cotangent. And the period length is pi. Now we need to look at their vertical asymptotes. If I have cotangent, that's cosine x over sine x. So there's going to be a vertical asymptote where the denominator is equal to 0, or sine x equals 0. So you want to look at your little circle that we drew. And from 0 to 2 pi, where is sine x equal to 0? Okay, and also at 0, right? 0, pi, and 2 pi. So those are going to be my vertical asymptotes. So I'm going to follow the same procedure. You make 4 tick marks to the right and label it the period length. So x equals 0 is the y-axis. X equals pi is at the 4th tick mark. Now I don't have 2 pi, and I actually don't need to put 2 pi on here. If I know that it's 4 tick marks apart to get to the next one, I can, because of the way I've drawn this, I can just make it over here at negative pi. However, there's nothing wrong with making 4 more tick marks, call it 2 pi, and put 1 there. Then we need some points. So let's do cotangent 0. Cotangent 0 is cosine 0 over sine 0. Oops, no, I don't need 0, do I? Whoops, we just determined that was a vertical
I just
asymptote.
trusted you, and I'm like, all right, I don't know what's happening.
Sorry about that. Well, let's start with cotangent pi over 2 then. That would be cosine pi over 2 over sine pi over 2. That's funny, you just trusted me instead of following. Okay, so cosine pi over 2 is 0. Cosine pi over 2, sine pi over 2 is 1. So that's 0. That's what I was thinking. And then cotangent pi over 4. Remember, that's the reciprocal of tangent. And we said the tangent of pi over 4 is 1. So cotangent is 1. And cotangent 3 pi over 4 is 1 over tangent 3 pi over 4. Well, that's negative 1. Okay, do you understand that? You get it kind of quickly then on your tangents. It's a reference angle of 45 degrees. All students, it's negative there. So the only difference here, we have the asymptotes are in a different spot, and it's now a falling function, a decreasing function, versus tangent is an increasing function. Alright, so then when I want to do cotangent, and I do any sort of wiggling with it, I know that cotangent is at the y-axis and the 4th tick mark. Okay, and then I just go from there. Now let's try to write the vertical asymptote in general. If it's 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, does anybody want to try this one? How could we write it in general with an n? Tyler, what do you think?
It would just be n pi. Wait, what was the period? Pi, and then in the set of integers.
Yeah, and I don't need to do 0 plus, and I don't want to do pi plus n pi. Do you understand that n pi will do the job for me? Because that'll produce 0, but it'll produce 1 pi, 2 pi. And you guys do remember what an integer is. That's 1, 2, 3, 4, 5, but 0, negative 1, negative 2, negative 3, negative 4, negative 5, and so on. Alright, so there's your vertical asymptote. The only time the vertical asymptote changes is if you change the period length, or you can move these left and right. That's where it gets really tricky. Once you shift it left or right, that's going to adjust where the vertical asymptote would be located. Okay, so let's recap here. Tangent is typically at the 2nd tick mark right and left. Cotangent is at the y-axis and the 4th. And you just go 4 right, 4 left.